Hi, I'm Meta Spencer, and I'm welcoming everybody to this series called Cool Thinking, which is a series of 35 shows that we're producing, forums, I like to call them nowadays. And this series will all, some way or other, help us understand the options and possibilities for cooling the Arctic and of course both poles, and trying to keep the ice from melting, which is one of the great catastrophes impending as global warming proceeds. We want to find ways of chilling the Arctic. So we will have almost every Monday until October. We will be having a conversation with some experts, and sometimes with some people who are not experts, whose job will be to help make sure that we pitch our conversations at a level that ordinary citizens can, and followers and audience can understand. So sometimes we'll have people joining us for that purpose. Anyway, I'm delighted today to have three guests, all of whom are experts on the serious threats that we all face having to do with the melting ice at the polar regions. And I think I will introduce Dr. Brian von Hersen first, because he's so far away, he deserves special treatment. Brian is I presume you're in Australia, are you not, Brian? That's where you live. Okay.
Yes. Those are the hinterlands of the Sunshine Coast of Queensland, Australia.
And it must be about middle of the night for you now, right?
It is. Yes, it's a wee hour of the morning, but I'm very happy to participate in this talk today.
The second most distant person from me today is in Turin, Italy, and it is Dr. Peter Wadhams. Peter Wadhams is probably, my guess is that he's the most distinguished and well-recognized name as an authority on Arctic sea ice of anybody in the world today, and he's very generous with his time for us.
Thanks.
Good. All right, and a lot closer to home, in Ottawa, I believe, is my friend Paul Beckwith. Paul is a climatologist. I don't know what kind of title you claim for yourself most. Doesn't matter?
Call me what you want, yeah.
Good morning, friends. Now, what we are doing, as I alluded to, is we're going to have a series of 35 different forums in which we'll invite distinguished guests who are all experts on global warming and primarily on things that can be done, allegedly, or we hope, to use mostly technology to keep the Arctic and the Antarctic colder than they are doomed to be otherwise, because they're melting and we see catastrophe looming. So there are various people who've come up with proposals. The most common terminology for calling these things by one name is to say that they are geoengineering proposals. That's a term that some people avoid using, and I'm not afraid to use it because I think we better at least come up with some common language to refer to it. And one of the technologies, and probably, well, I don't want to pick my favorites so soon, but one that I find quite credible is called marine cloud brightening. And that is a technology that involves, to put it very simply, spraying tiny particles of seawater into the atmosphere where they go up into the clouds, and tiny pieces of particles, droplets, are lighter and in color. They're white. And the darker, the heavier and bigger droplets are darker color. So when you change the composition of a cloud in the direction of making it more light weight particles, you lighten the cloud, and that creates the greater reflectivity, make the cloud whiter, and it reflects light more, of course, than a dark thing does. And therefore, incoming radiation from the sun gets deflected or reflected back into space. which cools the water underneath, and you only do it over water. I don't know whether that's an adequate summary to explain what the whole thing is about yet, but let's see if Brian can correct my version of marine cloud brightening. Yes, Brian.
Well, I think it's worth mentioning that these particles, so to speak, are the very sea spray that you see when you go to the beach. If you were go down to the beach and you look up and down the coastline, you'll notice a bit of haze along the coastline where you may see some sea spray that is caused by the waves and whatnot, and it looks a little hazy if you look up the coast or down the coast. And so those very same sea spray particles that make the ocean so the beach experience so healthy. It's really got some wonderful, very healthy ions in the atmosphere. It moisturizes the air. It's really quite a natural phenomenon, the sea spray. So I think it's important to mention that this is such a natural process that we experience every time we go to the beach on a windy day.
Mm-hmm.
Or wavy day, I should say.
That is very interesting. And maybe you want to even explain, I can't talk about the chemistry of the thing, but tell me, maybe you want to explain how it works. How does this happen that if you spray salt water into the air, it would have that kind of effect?
Yes, well, it's pretty simple. Those little droplets of seawater, some of them are less than a micron in diameter, they go into the air as a natural part of wave motion and bubbles popping and everything that happens on the beach when you have waves crashing on the beach. And those droplets of seawater evaporate in the air. They actually dry out and turn into little salty particles. Just like if you're going in the water, you'll taste that it's salty. Well, that salt becomes a little tiny salt crystal, and much like you put on your eggs in the morning. And that salt crystal is small enough to float up to the base of the cloud layer. There's this layer called the boundary layer of the atmosphere that's between the seawater and the bottom of the clouds, and that's a convective layer. Just like as you're heating up water or a stew, you'll notice it's turning over. Well, the sunlight will warm the surface of the earth, and it will cause the air to go up to the clouds, and then the air will come back down again. That naturally transports those little sea spray particles to the clouds, where they can help form what's called cloud condensation nuclei. It's the tiny little salt particles that help produce a droplet that forms a cloud.
You see, for a long time, I didn't realize. I thought you had to spray it upward to, push it to get it up into the clouds. But what I'm told is that it will naturally be lifted up to the clouds. Yes. You call this convection or something? Okay, good. I see.
Yes, and it's from every day we have sunlight hitting the surface of the earth, and it warms the surface of the earth and causes the convection to go up to the clouds and then back down again.
So we want to talk about this as a possible mechanism that could be exploited and used artificially. That is to say, we could have stations along the coast or maybe on ships in the ocean. And particularly, I'm interested in whether it could be done in the Arctic Ocean, because that's where we most urgently need to keep the ice frozen. And that's Peter Wadhams's main concern, I think, too, is the Arctic ice. So I want to talk about that, but I also want to introduce somebody who's just joined us, and that's Dr. Adele Buckley. I have just last year, we ran a series of shows about various technological proposals for solving global warming or reducing the problem. And we had members of the Canadian Pugwash group join us so that they could help keep the conversation steered to a direction that our audience might find useful. And Adele was frequently with us. She is a physicist and an engineer and a very active person in the international Pugwash community. So good morning, Adele. How are you?
Good morning, everyone. Apologies for losing track of the time, but I'm here now. And
Okay.
I must say, I am concerned about when if you see a cloud that's appropriate, does it last long enough to actually receive the spraying that is occurring?
Hmm. Excellent question. I think maybe that's a good thing to ask Brian. Oh no, let's move on to Peter Wadhams because I want to tie that up to the Arctic as soon as possible. I understand that this system of marine cloud brightening really it might work better, more easily if carried out in warmer climates than in the Arctic. The Arctic is not the easiest place to use it, but it may be the place that is most necessary because we most urgently need to do things quickly to solve the Arctic melting ice. And so please answer my question if the Arctic is a good place, and Adele's question as to whether the clouds don't maybe they move too fast to make it really a practical solution. Peter?
Well, this is a good question, so therefore I'll pass it to somebody else to answer because I'm not sure what the answer is there. So maybe Brian would like to answer that question.
Well, Brian's got his hand up again. So, Brian.
Yes. Well, I actually am a pilot of 3,000 hours, and I'm very happy to say that I've flown through the Canadian Arctic, of which you speak. And I've seen many times what's called a marine stratocumulus cloud layer, which is a gray overcast, which I'm sure you're familiar with if you've spent time around Hudson Bay. And those are the very clouds that we're seeking to re-brighten. And why do I say re-brighten? Because NASA satellites, and in fact the Big Bear Solar Observatory, have confirmed that our planet is dimmer and duller than it was just 20 years ago.
Really?
And that is a profound realization. But the NASA Ceres satellite has been doing measurements for over 2 decades and has actually measured the reflection of the Earth. And we've gotten dimmer and duller over the last 20 years.
Fine.
As well,
Do
it's
they know
both
the mechanism?
yes, it's due to the sea ice and it's due the loss of sea ice and it's due to the loss of marine clouds. So in many ways, we have to re-brighten the planet in order to get us back to pre-industrial levels of reflecting the sunlight from the Earth back into space.
Why would we have lost marine clouds? See, I mean, I'm familiar with most of the stuff about global warming, the effects, but I haven't heard anybody say that we're having fewer clouds because of it.
Yes.
What's behind it?
Meta, you need to read some of James Hansen's papers and letters that he puts out frequently.
Mhm.
You can learn about the reduction of sulfur in marine shipping fuels, and sulfur act as cloud condensation nuclei. So the absorption of solar radiation on the surface of the Earth has greatly increased, mostly, more than anywhere else over the oceans. With the tightening of regulations on sulfur emissions by the International Maritime Organization, you can measurably see that there's far fewer clouds over the oceans in the northern hemisphere, especially. So the Earth is absorbing way more sunlight. I mean, the Arctic albedo has decreased, significantly. So the Arctic is darker; it's absorbing more sunlight. The other thing is this method of marine cloud brightening does not actually modify existing clouds. Okay, existing clouds, have a certain lifetime, quite dependent on things like the number of collisions between water droplets because they coalesce and then they rain out. So, clouds also can evaporate. So their lifetime is, in a matter of days generally. So what you're doing with marine cloud brightening is you're creating all of these small nuclei, cloud condensation nuclei, in a part of the Earth where there are very few of them, which is over the ocean. There's no source of these particles. So you create these small particles of cloud from salt, salt, you blow salt, so you spray salt, seawater through sprayers, the water part evaporates, it leaves the salt crystals behind, they're acting as cloud condensation nuclei. they're there to, and you can get, when you get clouds forming, if you get clouds forming in that region, those clouds will consist of very small water droplets, making them very, very bright by the Twomey effect. Okay, this is what Stephen Salter's been talking about for years. So you get these brighter clouds, and therefore they reflect sunlight, and you can cool the planet that way. So can we create them in the Arctic? Well, there's different ways where you want to actually cool the air, for example, going into the Arctic. So you don't actually have to, one way to cool the Arctic is to stop all the warm air from going into the Arctic. So if you position sprayers and cool the ocean and the air moving into the Arctic, you can actually cool the Arctic that way, for example.
Okay, now look, Brian's point was that in the last 20 years, the world's gotten dimmer. But my understanding is that the change in the amount of sulfur emissions from shipping has been a recent thing. They only recently started making companies reduce the amount of emissions of sulfur or whatever. And that wouldn't explain anything that started happening 20 years ago. And I'm not sure whether Brian it could have been that there are only 2 points, the beginning and the end, that they're testing, and the change really happened last year or something, and the rest of the time it wouldn't have been any dimmer until they recently started this. Brian, set us right. Do you understand? By the way,
yes, they do.
Hand up. Nobody has to put your hand up. You can interrupt each other and even fight if you disagree.
Well, just that there's such a time delay here that it's helpful to have the electronic hand up as well. So in response to that, Professor Tapio Schneider at Caltech has confirmed that a warmer planet has fewer clouds, especially fewer marine clouds. And so this is something that is a significant effect. And in fact, the International Maritime Organization has, since 2015, almost a full decade, been reducing the allowed sulfate particle emissions in the marine area offshore, more than 100 kilometers offshore. And this is all in an effort. Near shore, it makes a lot of sense to reduce sulfate particles because there are significant health effects going on. But further offshore, these particles get rained out with every rainfall. So, after a week, they're all rained out. But that had a huge effect. In fact, I believe that Dr. James Hansen has identified that the change in sulfur particles over the last decade has been the equivalent of it's caused such a loss of brightness that it's as if we've added another 100 parts per million of CO2 equivalent to the atmosphere in terms of the radiative imbalance. Over the last 20 years, think of it as a temperature budget or a light budget. If you take the light coming in minus the infrared going out, you want to try to balance that budget to keep your planet at a stable temperature. But that budget has gotten sorely out of balance, several watts per square meter out of balance in the last 20 years. And this is a profound problem that's resulting in enormous heating of the atmosphere. In fact, the final phase of the IMO, International Maritime Organization, regulations went into effect just 1 year ago. And we saw last summer temperature anomalies of 5 degrees Celsius in the North Sea, and that is high temperatures there, and 101 degrees Fahrenheit in the Florida Keys, enough to kill most of the corals in the Florida Keys. A temperature of 101, if you stay in that water for more than a few hours, you're going to overheat and die. I mean, a person will die in that seawater after several hours because it's hotter than body temperature. And so what will the corals do? They have no place to go. How are they going to survive? And sadly, the first reef I ever dove on at the tender age of 18 was the Sombrero Reef down in Key Largo. And the New York Times had an audio podcast just last August, September, describing the demise of that beautiful Sombrero Reef. Just, the scientists that went down there said, "Oh, it's not bleaching. It must be okay." And they dove on it, and it hadn't bleached. No, it had simply died because the temperature was so high.
Okay, well, but the reason for requiring ships to stop emitting this stuff was a benign reason, a very laudable one. That is to reduce pollution, right? I mean,
Near shore, that's very important. Offshore, it's critical that we sustain our ecosystems. And it turns out the sea spray and, to some extent, the sulfate particles historically, but there are a variety of innocuous particles, including natural particles that are produced by the plankton in the ocean. All of these are important cloud condensation nuclei for forming those healthy marine clouds that keep our Arctic region cool. And so it does help in the Arctic. And one thing that I think is important to recognize, you probably remember all those wildfires in Canada over the past several years. Mm-hmm. Those wildfires, more than 1% of Canada was on fire last summer. And those fires produce black soot, which lands on the Arctic sea ice and on the glacier ice, and it makes it dark during the summer and absorbs. If it's dark, it's going to absorb a lot more sunlight and melt a lot more ice. Mm-hmm. And so we're getting an accelerating feedback from all those wildfires that are not only in Canada, but also in Greenland and Alaska that are contributing.
Actually, Peter, I believe after one of your trips to Greenland, we were talking and you were telling me about that particular concern. That is one of the issues that you've been addressing, isn't it? The soot or the other sources of blackening of the.
Well, yes, we just produced a report on that. In fact, there is. As Bruce says, that there's a big increase in the amount of deposit on the surface. It's like the surface is like a great sheet of blotting paper, absorbing dirt particles and ice particles, of course. But in the case of the present circumstances, it's largely dirt particles that are doing the damage. And we don't know really how to deal with that. It's just increasing the amount of energy that's absorbed.
Well, I don't want to change the subject exactly, but this is an appropriate time to mention the fact that one of the possible interventions that have been proposed as a way of keeping the Arctic sea ice white is something, well, I believe a woman at Stanford has proposed the sprinkling or somehow dispersal of tiny particles of glass balls all over the Arctic. Somehow this would reflect light and increase the albedo effect of the ice. And I didn't know, it was a real question whether we should have a special forum discussing that. I don't know whether that's realistic or not, but is that a relevant, you say, Peter, that you don't know what to do to fix it. Would this be one of the possibilities?
I don't really think so. I know it's being done and it's being proposed very vigorously, but the amount of energy involved, and also the surface, the stuff that you're putting on the surface doesn't stay there. I mean, it's absorbed into the melting ice. It sounds good, but I don't think it'll work.
Yeah, Brian.
Yes, I think it's important to mention that while reflecting the brightening the surface of the ice can help to some extent, really nature's way of doing this is marine clouds. Mm-hmm. It's wonderfully reflective. You'll notice that on a cloudy day, it's just 20 degrees cooler than it is on a sunny day. And that's nature cooling itself. In fact, there's some evidence that the plankton of the ocean actually contribute to these cloud condensation nuclei and help keep the clouds bright. In fact, the late Sir James Lovelock developed this as one of the Gaia theories of how does the planet keep itself cool? And it turns out the plankton have a great wisdom of several 100 million years on how to produce these natural particles that actually help to keep the clouds healthy and bright. And I think this is nature's way
What are these particles called? Because I'm not familiar with that.
Well, they're
Methyl
called,
sulfide.
yes, there's natural particles. You know, if you ever go to the ocean and you smell the natural sea spray smell, part of that smell are the natural particles that are produced by plankton. Dimethyl sulfide, when the plankton dies, it gives off this organic compound that we eat every day in small quantities. And it's a natural compound that goes into the atmosphere, and it reacts with ultraviolet light to form those little tiny particles that are natural that go up to the clouds and help brighten those clouds. And that's something that's been going on for millions of years naturally. And I think understanding how nature works to cool the planet is a great way to restore the kind of cloud brightness and really re-brighten our planet to where it was 20 years ago and earlier, a brighter and cooler planet. And I think re-brightening the planet is a great objective, both with the marine clouds and with the sea ice, to get us back to pre-industrial levels of reflecting the sunlight back into space, where, you know, it kept the planet cool for thousands of years, if not millions. And this is really a chance to get us back to a healthy climate.
Mm-hmm. I'm glad to hear it. But of course, we have clouds over land as well. And I wonder why you aren't suggesting brightening the clouds here, because you talk about marine clouds, not the kinds of clouds that I might see out my window. Why would you only do this over water?
It's important to recognize that the ocean is 70% of the Earth's surface. We should have called it Ocean Planet Earth. And so many people have said, you know, the climate is the ocean because the ocean has such a profound effect on the climate. So if we start there with the marine clouds, then those marine clouds actually drift onto land, as Adele has so aptly put. The clouds move. And so if we take care of our marine coastal regions, for example, Hudson Bay and the cloudiness that you'll get off of Vancouver or off of the British Columbia, or even the eastern shores, you know, that's a great place to start. And if we're talking about sea ice, this is a great way to restore sea ice, because when you have cloudy conditions, you're going to get less ice melting in the summer. And it's primarily in the summer and the autumn when you want to have these clouds in place so that they can reflect more sunlight and they can keep it cool enough so that the ice can, over summer, and actually start accumulating multi-year ice in the wintertime in the Arctic.
I think the main reason, Meta, is that marine cloud brightening only works over the ocean. It won't work over the land at all, because over the land there's thousands more cloud condensation nuclei than there is over the ocean. So if you're making small cloud condensation nuclei over the land, they're just going to be a small part of they're going to only generate a small fraction of the water droplets in the clouds, because we produce all kinds of particles, you know, on our industry, sand blowing, you know, there's all kinds of particles in the air over land, whereas over the ocean, it's pretty much pristine. There's very, very few particles. So creating small cloud condensation nuclei over the ocean makes a huge difference to cloud generation there, whereas it wouldn't over the land. The other thing is Leslie Fields is the woman with the company Ice 911 that has proposed the glass to brighten the Arctic.
Thank you. I couldn't remember her name, but I appreciate that.
Yeah, that's the woman that you're talking about. So, but I would argue maybe you should put your thoughts towards lobbying the IMO and getting them to put sulfur back in their shipping fuels and removing it slowly. I mean, it's like Homer Simpson is in charge. You know, they just suddenly said, okay, let's take all of the sulfur out, which they're doing. You know, they have no idea on any of the science behind what that sulfur does in the atmosphere in terms of helping to cool the planet. They just have no idea, and our governments are ineffectual in trying to, you know, they're always too slow. They always do things after it's already happened. So, you know, we have to keep trying. I'm not saying we can't keep trying ideas and doing things, but I mean, we've left it too late. I mean, the planet, the warming is so fast and accelerating so quickly. You know, there's a paper out just in about
Let's assume that we could actually counteract the effect by spraying salt to make up for the deficit of sulfur from the shipping. How much of the salt water would we have?
Yeah, but we're not going to do this anytime soon, are we?
Well, I don't know.
We're not going to do it at scale. I mean, you know, we have to be realistic here. Like, none of this is happening, right?
Well, but we're going to make
we can all have our ideas and say we need to do this and do this, but the reality is none of it is happening, and our planet's acceleration, warming.
Pugwash is going to lobby the Canadian government, so let's see if we can get some action there. Ryan,
okay, we'll get them to put sulfur back in the shipping fuels. That's a good start. Brian. It can be done very quickly.
That's not necessarily a good worth putting the effort into. I have excuse me, a few thousand comments and questions, but
yeah,
the ocean is like one ocean. It's not a multitude of different oceans, and I don't see why it's important to choose the Arctic.
Can I make a comment?
It's a difficult place to work, and a very difficult place to set up, and so it seems that you could get a lot more effect if you would go somewhere not the Arctic, because it's less expensive, less trouble, easier to do. You can do more of it. So I realize also that putting glass beads on the ice is useless when we're soon going to have an ice-free Arctic in the summer, and all the glass beads disappear anyway. So that seems useless. But really, the Arctic, if Meta says, and of course it's true, the sooner that something is done, the better. But waiting until somehow you can do it in the Arctic seems like that.
In response to Adele, I think there are some key opportunities, and that is intervention begins at home. And rebrightening, for example, Hudson Bay or the British Columbia area, it's about getting those marine clouds back. And so it's something we can do in our regions and our communities. So it's something we can do offshore British Columbia, offshore California, offshore Hudson Bay, where communities want to regenerate their healthy climate. And that's about getting the brightness of the planet back locally and regionally. So, Paul said it's mainly over the ocean, but I do beg to differ. As a former resident of Southern California, those marine clouds were responsible for cooling tens of millions of people in Southern California, extending hundreds of kilometers inland, because those marine clouds, as Adele has aptly mentioned, go from the ocean overland, and they extend hundreds of kilometers and they actually cool tens of millions of people in Southern California, just as an example. So we have many places where that happens.
Of course, clouds blow over land, but you can't generate clouds over the land. That was my point.
That's not true. You can generate clouds over the land, Paul. Paul, I beg to differ. You can generate cumulus clouds all day long over the land, as you've noticed. If you in the morning it may be bright and clear, but by midday you've got some bright cumulus clouds that are reflecting sunlight very naturally. And so they're different clouds. And yes, there are cloud condensation nuclei. But instead of saying it doesn't work over land, I would simply say that marine aerosols and anthropogenic and terrestrial aerosols both contribute to cloud formation over land. And I agree with you on that point.
Mm-hmm. Okay. My reasoning for Adele, for why it's important to do it in the Arctic, is simply that the Arctic is such an emergency situation. I mean, I hang out with Peter Wadhams a lot, and Peter, remind us all that this is really, really an emergency situation, because I know it's on your mind a lot.
Well, it's certainly an emergency if you think about marine ecosystems. If you think about marine life in general, polar bears or something, you're wiping out basically a large part of the Earth's surface as far as its marine life is concerned. and that's obviously bad. But I don't know exactly how bad that is in relation to other things. But it's nasty, and if we can prevent if we can bring about freezing or bring about cooling of the Arctic, then we have achieved something useful.
Mm-hmm. Okay, fine. I'd like to ask about a little bit about the technology involved in this proposal, because this is a practical proposal, mainly coming in our previous conversations from Stephen Salter, a retired engineering professor in Edinburgh. And I'm sorry he can't be with us today and I hope he can be sometime in the future, because he has a very significant, a very specific kind of plan. He wants to create certain, he's designing ships that will be suitable for spraying in the Arctic, and a certain number of them are required. He's figured out how much needs to be done, where it's suitable to do it, how much it would cost, more or less, that kind of level of planning. So he's not here to make that pitch, but we can do it a little bit for him, at least speculatively. Brian.
Yes, I've been in touch with Professor Stephen Salter in recent weeks, and he has proposed sailboats that use wind energy to actually provide the sea spray. And this is sea spray that you'd see on any windy day with white caps and bubbles on the ocean. It's really that type of sea spray that's actually helping to produce the small submicron particles that can help form those clouds. And so Professor Salter's sailboats will use wind energy to actually restore the particles that are needed to keep those marine stratocumulus clouds healthy and bright. And I think the objective is during the summer and the autumn, especially, to have these clouds in place where they can do a lot of good, and especially in the Arctic. And
Oh, I beg your pardon.
There we go. For every degree of global warming in the temperate latitudes, we have 3 or 4 degrees of warming in the Arctic, and that's why it's so important for us to address the Arctic. Not to mention that sea ice is so responsible for keeping our jet stream stable and ensuring a healthy climate for 7 of the 8 billion on the planet who live in the northern hemisphere. And so this stable jet stream is essential not only for the Arctic, but for all the temperate latitudes to ensure reasonable weather throughout the year. Thank you.
Okay, good. Adele, I think you have an issue.
Really have to, one, react to the idea of Stephen Salter's boat, or boats or whatever. It seems to me that they may work in temperate places, but in order to go to the Arctic with such vessels, they will need to be outfitted, especially for the Arctic, and will cost a huge amount of money to do that. And planning any Arctic expedition is a big deal. And I'm sure that you would all agree with that. But the other thing is, have you ever looked at the map and thought how to get to Hudson Bay? I mean, if you can go maybe from Halifax, and you have to go up and around Iqaluit and the Davis Strait into, you cannot just say, oh, well, we could go offshore in Hudson Bay and spray. It's not the most accessible place. It's extremely inaccessible. So I really think we should be a little more realistic about ever thinking about Hudson Bay as a place to do any of these things.
Well,
that's a great question.
For one thing, though, I mean, Hudson Bay, one of the problems is it's probably already too warm. We'd like to go to a place that's farther north. But the other thing is, Adele, there's a train that goes to Churchill, Manitoba, and you could bring in lumber and whatever and have the boats built there. So it isn't absolutely out of the question to have it done locally, and it'd be very good for the economy.
It's a very big project, and as you say, we need to do something now, and this would not result in something now. Whereas sort of going off the coast of BC or any other place which is more accessible could easily see us doing something now. I'd just like to mention one other thought that never seems to come up, uh, which is that the world shipping industry is looking forward to the ice melting, and they're a powerful force, and I cannot see that they would have the slightest uh, support and would probably hugely object if it was actually possible to refreeze the Arctic. You'd get a huge amount of objection. And of course, finally, putting all this effort into um, doing this cooling doesn't do a thing for reducing the carbon dioxide, which of course we all know. So anyway, there's difficulties, but I see it as important. But I think the Arctic is the wrong place to focus on.
Okay, in response to Adele, I've got several comments. The first is that temperature and carbon dioxide are covariables, and that means they both vary together. It's not cause and effect. Okay, it's that the planet Gaia, has these two aspects of the atmosphere very hand in hand, and so that's really important. Secondly, it's important to recognize that there are multiple ways to re-brighten the planet and to provide the sea spray. And it's not only with Stephen Salter's sailboats, but we have many examples of wind turbines in Alaska, thousands of wind turbines that are fairly affordable, that could come in on train to places like Churchill and be deployed, and they can provide renewable power to those communities to have a reliable source of renewable power 12 months a year in the case of wind turbines in the Arctic. It's plenty windy up there. And then furthermore, that excess energy can be used to restore the sea spray and re-brighten those marine clouds in a region like the Hudson Bay, if desired, on a community by community level. This is something that local regions can choose to do and have community-led projects that have local effects and local benefits. And so I think that's important to recognize that we can choose where. In fact, we're also looking to use solar power, solar PV, to actually provide the energy and solar thermal to provide the energy that's needed for the sea spray. And getting the sea spray back is going to make a huge effect on and actually restoring these marine cloud brightness and ensuring that we have the clouds that we need in the summer and the autumn to keep the Arctic cool, and also, for that matter, to keep the Great Barrier Reef cool and to keep our ocean cool, which is absolutely essential to the health of life on Earth. Thanks.
Well, tell me in a practical way, how can you start this process?
Well, I think we start at small scale, hectare by hectare, and by engaging with local communities. We say, let's do a trial to, restore, let's say, the brightness of our region. And that could include municipalities from Hudson Bay to British Columbia to the coast of California or Australia, for example. These are all places where marine clouds have a profound effect. I will say that our climate in California and also in Australia is greatly affected by the brightness of these marine clouds. And restoring that brightness is important from the Arctic to the equator. So I think that's really essential to recognize that 20 years ago, we had a brighter planet, and we have to work to restore that brightness of that planet, of this planet in our generation, to keep our climate healthy enough that we can actually balance our carbon budget as well as our temperature budget in the coming decades.
Thank you. And Paul?
The first place for a large project, where is that?
Let Paul answer.
Okay.
Well, I think, yeah, I think we need a few. Adelaide's looking for some specifics, Brian. I mean, you're talking about, okay, so you want to put some cloud condensation nuclei over Hudson's Bay to create some low-level clouds, right? So how do you do that? Do you send up sailboats that can with spray nozzles on the trains that go up to Churchill? Do you know, how do you do it? You can't build anything up there. There's no infrastructure to build stuff. You have to ship it there. You can either go, if you go by ocean, you have to go into the far Arctic and then go south into Hudson's Bay, or you ship it up by rail. So obviously you're talking about rail.
Yeah,
right?
I would recommend the rail approach, and I would furthermore recommend social engagement with the communities. That's where
Okay,
things begin.
who's
We
going to pay
engage
for
with
this?
those communities. I'm sorry. We engage with those communities and ask who wants the renewable power, who wants to revitalize their communities, and who wants to restore the healthy climate that these communities have enjoyed in previous decades. When those communities sign up for community-led projects, we engage with them and raise the resources that are needed to provide the renewable energy, the wind power, and the solar energy that can actually make a difference. And that excess energy can be used to actually restore the sea spray, restore the marine cloud brightness in a region, and that can be measured by satellite and by other sensors. So it's something that can begin community by community. And I would say Hudson Bay is certainly a candidate for the Arctic, and I would say the British Columbia region is fine, and we should engage with those local communities and with Indigenous and First Nations peoples to actually work to regenerate healthy climate in their regions, one at a time.
So are you suggesting that the Canadian government is going to fund this, or are you suggesting that private corporations are going to fund it?
Well, I would say to begin with, we need to look at a grassroots effort where we have people around the world and communities. It's really at local levels and people who care about the climate who are going to make the initial steps to actually restore the healthy environmental conditions that provide us with kind of a pre-industrial healthy climate that we've enjoyed in previous centuries. So I would say simply that it will start with communities, local representatives, and people who care, who are watching this program perhaps, who can actually help to get projects started at the community level that will show the way forward. And once we've shown the way forward, then yes, state and federal governments will eventually come in and enable this to scale. And so it's going to require, the future is here today. It simply requires that we do the small projects today that will show the way towards large projects in the future that can be responsible and safely done.
A couple of years ago, or maybe just a year ago, I was asking Stephen Salter how much it would cost, because he believes that you can do a pilot study in the Canadian Arctic or subarctic with something like $30 million. You would have maybe 4 different stations where people would be spraying seawater. And so the question is, where would you get $30 million? There are, of course, I don't think you're going to go around asking people living in these Inuit communities or to look into their piggy banks. I think we really have to go to somebody with deep pockets, some billionaire or that maybe we can find somebody who could fork over $30 million to get this going. And he thought it would have to take about 5 years to get it going. I agree with Adele that it's going to take a little longer than I would like to see it take, but some of the other technologies may be something that can be done more rapidly. Brian?
Yes, for less than $1 million, you can install an Arctic marine wind turbine that can produce 100 kilowatts of power. And that's probably including shipping on the train, by the way, up to Churchill. And so, it can be done at a smaller scale. For less than $1 million, you can install a turbine that can power more than 100 homes, I would say. And then furthermore, we can also do at small scale the solar photovoltaic projects and the solar thermal projects that can demonstrate that this works at the shoreline and show that it can be done at a small scale and then can be scaled up. And so I would encourage us to consider the small solar projects to start, the less than $1 million projects that can include a wind turbine that can provide power year round. And then furthermore, eventually, of course, Stephen Salter can work at a larger scale with his marine vessels. So we start small and work larger, and there are a number of small projects we can do for less than $1 million.
Mm-hmm. Okay. I'm sold, but Adele is sold. What do we have
to know who is we? I mean, if you got a community on Hudson Bay or Haida Gwaii or somewhere to agree that they would want to do this, I swear it would take a number of years before it actually was fielded, whatever it is. And that's
I
only a
think
demonstration.
once the funding was in place, we're developing the approaches now that will be able to be deployed in just a matter of months. So it's less than a year to put this in place in a community. Of course, the funds have to be raised, but once they are raised, the project can be deployed in just a matter of months. It takes just a few months to put a wind turbine into place or a solar PV system. So this all can be done, and it's not very difficult.
Mhm. Okay, I think that is a reasonable thing to look forward to. Peter, what do you think about all this? You and Stephen talk about this a lot. Is this something that we could realistically achieve within, say, 5 years? You think?
Yes, I think so. I think Brian is very optimistic, but I think it's well placed optimism. These are things which, first of all, they have to be done. At a certain point, we've got to be able to deal with this problem, and secondly, it does look as if there are ways of doing this that can bring us to some useful conclusion within months. And if so, then that's really something that's very, very important, and we should go for.
Mm-hmm. Well, I like the idea of consulting the Indigenous people most of the people living around that area are Indigenous Canadian people, and they need to be asked because it's their livelihood, their environment that we'll be tampering with, and they need to be consulted. But also they need jobs because their livelihood is already being impacted adversely, and it's necessary to provide alternative ways of employment for them. Paul, you were joining forces, it sounded like, with Adele a little while ago, voicing skepticism. Let's give you, I don't want to give you the final word, but I want to give you one more opportunity to take sides in this thing. And then anybody else who wants to wind us up, because we've got to finish.
Yeah, I think it's hard for me to be optimistic about any of these methods at the moment. I at this stage, I've lost all faith in Western leadership and Western governments for many reasons, and also I just see, I read all of the latest climate change science and articles and so on and so forth. So, I just think we've left it too late. Our civilization is, we need to try all these things. Don't get me wrong, but I'm very pessimistic at the moment about our future. So these sort of things, putting a wind turbine up in Hudson's Bay, I don't think is going to change the world. What I am curious about is, Brian, in Australia, are you there for work? Or are you there for vacation or holiday? Or what are you doing with marine cloud brightening work in Australia? Is there anything happening there? That would be my question to you.
Well, Paul, yes, there's been work done with a group called RRAP on the Great Barrier Reef to try to restore cloud brightness to reduce the amount of coral bleaching that happens in the tropics. It's early work and more work needs to be done, but we do have a volunteer effort at rebrighten.org to actually work to rebrighten the planet with marine clouds and sea ice. And of course, this is being done at a very local scale right now, but we're happy that Stephen Salter has been part of our effort and other experts from around the world, including the Cambridge Center for Climate Repair and Dr. Armand Neukermans in California. So this is a global effort that we're doing. I think it's important to touch on what Meta has described, and that is, it's not only getting the social acceptance from our Indigenous communities, but actually co-designing these approaches with those communities so that they can have the renewable power that they need, the sustainable livelihoods, and to work to actually regenerate healthy climate in our generation. And that starts at a local and regional level. So it presents a great opportunity for us to do it. I think it's important for us to say that this is all part of the climate triad. And the climate triad is really three things. It's getting our emissions to zero. It's about drawing down the 1,000 gigatons of carbon that we put in the atmosphere in the last 2 centuries. And it's about climate repair. And this notion of marine cloud rebrightening is about repairing our climate back to pre-industrial levels. I like to say the future is here today. It's just not broadly distributed yet. And to quote the very famous Winston Churchill, he said, "You can count on the Americans to do the right thing after they've tried everything else." Thank you.
Okay. That's, I guess, an encouraging pep talk. I'm not sure. It didn't pep me up exactly, but it's the best I can do, considering that Adele and now Paul have taken a stand in the other direction. I remember a year ago when I used the word doomsday, and Paul said, "I never talk that way." And I guess you changed your mind, because you sounded pretty doomsday-ish to me.
Well,
Anyway,
look, I mean, I'm just trying to be realistic. I mean, are we going to have Trump as U.S. president in 10 months, less than 10 months? You know, then everything that the U.S. has done on climate is down the tube. Look at oil production of the U.S. It completely dominates every other country in the world. So I'm very realistic, I think.
I get it.
You know, I just happen to be, this is the morning when, you know, the bottom line for me, and take this out of the tape, but the bottom line for me is for 3 or 4 months, 1.8 million Gazan Palestinians have been forced into a small part of Gaza. And Israel chose the Super Bowl to go and bomb and maim and kill people, you know, and the media, all the media says is 2 people rescued. So I'm sorry, I just I'm not in a mood for rainbows and unicorns on climate. I mean, things are worsening. You know, we can try all these things, but until we have governments cutting back on their fossil fuel production, right? Until we have you know, realism in our Western leaders in fighting the climate crisis, you know, then I find that it'll be difficult for me to have optimism that we're actually going to do anything about this problem, because, you know, I don't know if you saw the news about the Mauna Loa CO2 levels, right? In one day, they just jumped 4 parts per million, and they stayed up at higher level. You know,
What
the wind was probably
that? I don't hear anybody speculate.
Yeah, I mean, you know, probably the wind shifted from the north is what some NOAA scientists think. And if the wind shifted from the north, there's a lot of CO2. The hot concentrations are higher there. So, you know, it's hard to say, but you know, we're getting all of this stuff coming along. Also, the papers on the AMOC, the Atlantic Meridional Overturning Circulation, right? There's lots of that's been in the news a lot in the last couple of days. There's been some new papers on it. Stefan Ramsdorf has revisited some of his work from, say, 6 months ago, where he talked about some of the effects that would happen if that thing shuts down. You know, basically, a lot of Europe loses the ability to grow food. Okay, so this is obviously huge stresses on global food shortages. So you know, yeah, I apologize for being a bit of a pessimist and downer on this sort of method, but that's just you know, the way things look to me right at the moment from my chair. Yeah. I encourage all of this stuff, but I'm just getting very skeptical that any Western government will actually treat climate change seriously. They get distracted so easily by other world events coming along, and we're not.
I don't think anybody has to be optimistic. I'm not optimistic, and I don't operate on the basis of hope. People say if you don't have hope, you can't do anything worthwhile. That's not true. You can operate on the basis of duty. And I think, you know, There's not a lot of hope that these technologies are going to make any difference. But it's pretty damn clear to me that without them, we're sure sunk. You cannot get there just by emission reductions. So the most important thing that I know of is to keep plugging away at saying we have to use alternative, more aggressive types of technologies that can actually remove carbon from the atmosphere and reflect sunlight away from the planet so that we can directly cool the planet through albedo effects. So those are two things that are the most promising. They are the most realistic, and I'm going to keep fighting for them, even though I agree with you. The prospect is not really very bright right now. And I'm going to, who wants to have the last word? Please don't. Okay, who wants to say goodbye?
I just want to say, look, I am much in favor of action, and I think it is counterproductive to talk about action in the Arctic because it's more difficult. Get going on action in easier places, and the sooner the better. That's what, and just stop talking about refreezing the Arctic.
I think you're wrong, Adele. Brian, you have the last word.
I think it's important to engage with our communities, Indigenous and First Nations and local communities, for groups that want to make a change that can make a difference in the world. And that can start on our coastlines. It can start in Hudson Bay. It can start in any community that really cares about the climate and cares about their future. These local projects can really show the way forward because it is not hopeless. And I think we need to call people to action. There is basis for actually enabling nature to get back on her feet. And, you know, we've said for decades, we've observed that give nature half a chance and she'll rebound exponentially. And we simply need to give that small helping hand to get us back to healthy environmental conditions that can support healthy climate in our communities, starting on our coastlines and extending across the planet, because that's our responsibility, as you've so aptly put, Meta, is to actually be the change that the planet needs on a planetary timescale.
Thank you, Brian, and thank you all. And I want to encourage everybody who's been watching this to keep in touch with us. Our website, tosavetheworld.ca, will post these shows every week, almost every Monday. Or rather, we'll do them on Mondays, and it'll take a day or so to get them onto our website in an edited form. But keep watching that, because we're going to have a series of 35 discussions that are all relevant to the question whether or not any of these technologies are really promising in the prospect of chilling the Arctic and the Antarctic and helping to keep the ice that we have, or even Adele doesn't want to use the word, but refreezing the waters there. So thank you all for being here, and I'm sure some of you, if not all of you, will be back again as we revisit this topic and related issues about alternative technologies for cooling the Arctic over the next 6 months. We'll be doing this until October. Thanks again, and see you soon. Bye. Project Save the World produces these forums. This is episode 587. You can watch them or listen to them as audio podcasts on our website, tosavetheworld.ca. People share information there about 6 global issues, and we welcome your comments too. To find a particular talk show, check the scroll list on the homepage or use the search bar. Project Save the World also produces a quarterly online publication, Peace Magazine, which now serves as a free of charge newsletter to help mobilize knowledge about 6 global threats to humankind. We gladly email the magazine as a PDF or link to any interested organization in the world that works to prevent a global catastrophe involving war and weapons, global warming, famine, pandemics, radioactive contamination, or cyber risks. Just email us at office@peacemagazine.org and we'll add your group's email address without charge to our list. Please type "Subscribe my group" as the subject of your email. For individuals who wish to subscribe at $20 Canadian per year, go to pressreader.com on your browser and search for Peace Magazine.